National University Sudan, Faculty of Administrative Science. Good day, everyone, and welcome to today's Microeconomics Lecture. Today's topic is producers' equilibrium, one of the most important concepts in production theory. In previous lectures, we studied consumer behavior and how consumers maximize their satisfaction given limited income. Today, we shift our attention from the consumer to the producer. Every business faces an important question. How can we produce goods at the lowest possible cost while maintaining the desired level of output? Or alternatively, if we have a fixed production budget, how can we produce the maximum possible output? The answer lies in understanding producers' equilibrium. By the end of this lecture, you should be able to explain producers' equilibrium, define isoquants and isocost lines, understand the marginal rate of technical substitution, MRTS, explain the equilibrium condition using the tangency approach, apply these concepts to business decision making. Let us begin. Producer's equilibrium. Producer's equilibrium refers to the position where the producer uses available resources in the most efficient way. The available resources in the most efficient way that possible to him. There are two equivalent ways of looking at this concept. A producer may wish to produce a certain quantity of output while spending as little money as possible. Second, the producer may have a fixed production budget and wants to obtain the highest possible output. Both approaches lead to exactly the same equilibrium point. Think of a factory producing shoes. The factory combines labor and machinery. If it hires too many workers but very few machines, production becomes inefficient. Similarly, if it buys many machines but employs very few workers, the machines remain underutilized. Therefore, the producer must find the best combination of labor and capital. Economists analyze this decision using two important tools: the isoquants, equal product curves, and the isocost lines, equal cost lines. These tools help determine the optimal combination of production inputs. Let us start by defining what do we mean by an isoquant or iso product curve. The word iso means similar or the same. It shows all the combinations of two inputs. We cannot use more inputs because we use the graphical models where we have two axes only, the x-axis and the y-axis. So we use L, which stands for labor, and K, which stands for machines that yield the same level of output Q or Q dash. So output is a function of labor and capital, and that will give you constant quantity. That is why we put a bar up the letter Q. The properties, therefore, every point, or however, instead of showing equal satisfaction, it shows equal output. And it looks or similar to an indifference curve in consumer theory. Every point on an isoquant represents a different combination of labor and capital. Let me show you the graph from here. If this is the y-axis and this is the x-axis, Let us assume that we put the K in the y-axis and the labor in the x-axis. So this is an isoquant. This is an isoquant. And we have different combinations from labor and capital. Let us say 5 and 1, 4 and 2. I'm sorry for my bad drawing. 3 and 3. But we will have similar quantities. Quantities will be the same. The output will be similar. That is why we call it isoquant. So every point on an isoquant represents a different combination of labor and capital that produces exactly the same quantity of output Q bar. For example, suppose a company wants to produce 100 tables. It might produce those tables using many workers and fewer machines, or more machines and fewer workers. Both combinations may produce exactly 100 tables. Therefore, they lie on the same isoquant. Now let us discuss the properties. The first property, isoquants slope downward. Why? Because if labor increases, capital must decrease to maintain the same output. Second property, isoquants are convex to the origin. This reflects diminishing marginal rate of technical substitution. We will explain this shortly. The third property, higher isoquants represent higher output. An isoquant farther from the origin always indicates greater production. Fourth property, isoquants never intersect. If two isoquants crossed, one combination of inputs would produce two different output levels simultaneously. That is impossible. A collection of several isoquants is called an isoquant map. It is look like this. If we have K here and L here, these are the collections of isoquants. Isoquant 1, 2, and 3. The collection of them is called isoquant map. So, the isoquant 2 will give you more output than isoquant 1. And isoquant 3 will give more than isoquant 2. They are convex to origin. This is the origin point, so they are convex. Convex is like this, okay? And downward is sloping, like this. We cannot have isoquant or two isoquant that intersects like this. If this is 1 and 2, they cannot intersect because normally upper isoquants will give more output, but if they intersect, they will give similar output. So this is not correct. Marginal rate of technical substitution. Now introduce one of the most important concepts in production economics, the marginal rate of technical substitution, or MRTS, between labor and capital. Marginal rate of technical substitution measures the rate at which one input can replace another while keeping output constant. Let us take this isoquant. This is capital and this is labor, like this. Here you use 5 machines, but only 1 worker. So if you want to increase the number of workers to 2, for example, you have to decrease the number of machines to 4, for example. So the rate of change, you have here delta K, the change from 5 to 4, and you have delta L from 1 to 2. When you take delta K divided by delta L, actually this is the marginal productivity from labor divided by marginal productivity from capital. This is actually the slope. It is the slope of the isoquant line. So the slope, this is the slope, and it's equal to the rate of change, because as you studied before that, the rate of change in the y-axis divided by the rate of change in the x-axis is always the slope of the isoquant. So this is called marginal rate of technical substitution. So suppose a factory adds one more worker. If production remains unchanged, perhaps one machine can be removed. The amount of capital that can be replaced by one additional unit of labor is the marginal rate of technical substitution. And it is equal to marginal product of labor, marginal productivity of labor divided by marginal productivity of capital. As labor continues replacing capital, each additional worker replaces fewer and fewer machines. This phenomenon is called the law of diminishing marginal rate of technical substitution. And that is why isoquants become flatter as we move downward. Look, it becomes more flatter like this. To start like this, so it becomes more flatter, because you cannot replace more and more from capital with more worker. It means that it will be more, less and less when you replace for more labor or capital. This reflects the reality that labor and capital are not perfect substitutes. You cannot replace workers totally by machines, because machines also require workers to operate. And you cannot replace machines totally with workers, because manual work is very hard and it takes time, so it requires machinery efforts. This reflects the reality that labor and capital are not perfect substitutes. Eventually, adding more labor without additional machinery becomes less productive. Let us come to the iso cost line. And I told you before, the word iso means similar. So here we mean similar line. This is the iso cost line. It looks like this. This is capital and this is labor, and this is the iso cost line. It's a straight line. And we have, here are the more conservative points where you spend your total cost is on machines and zero for workers. And here you spend your total cost on workers and zero for machines. Now let us discuss the second important tool, the iso cost line. An iso cost line represents all combinations of labor and capital that cost exactly the same amount. What do we mean by this? If this is combination A and this is combination B, this is combination C, this is combination D, and this is combination E, all these combinations are or have similar cost or constant cost. So suppose a firm's production budget is $10,000. There are many different combinations of labor and machinery that together cost exactly $10,000. So let us take, this is the cost of labor and this is the cost of capital. Why do we say W? Because it is wages. Normally the cost of wage multiplied by number of workers, and this is L. So L is number of workers and wage is W, where R is interest, which is the price of capital, and K is number of machines. So when we multiply R by K, this is the cost of machines. This is the cost of machines. All these combinations are or lie on one isocost line. So the isocost equation is wage rate multiplied by labor plus a rental price or interest price multiplied by capital. Here, wage represents the price of labor. Rental rate represents the price of capital. By rearranging the equation, here we rearrange the equation and we put K as the method of law. So we will have C divided by R minus W divided by R and L. It's like this. We divide C, we put like this, C minus W, L minus R or equal R, K. C minus WL equal RK. We took WL to the other side, and when we move it, the sign will change. And then we left RK in the other side alone. Then we divide both sides by R. C divided by R minus W divided by RL. So it will end like C divided by R minus W divided by RL equal K. And then we obtain a straight line equation, and this allows us to draw the isocost line on the graph. We can do it for the K, and then we can do it for the L in order to. Properties of the isocost line. Let us examine the characteristics of the isocost line. First, it's a straight line, as I told you. This is the isocost line, where here is labor and here is capital, and this is a straight line. And the slope is minus W over R. It's a negative ratio of input prices. Its slope is negative because it is downward sloping. So this assumes that labor and capital prices remain constant, and its slope equals the negative ratio of input prices, and this tells us how many units of capital must be sacrificed to hire one additional worker while maintaining the same total cost. Third, if the firm's budget increases, the isocost line shifts outward, like this. This is K, L. So in case that the budget increases, so the isocost will shift outward. But if the budget decreases, here budget increases. Increase in budget. But if budget decreases, the isocost will shift inward, like this. This is K, and this is L, and here budget decrease. Okay? This means that the producer can now purchase more labor and more capital. Conversely, if the budget decreases, the line shifts inward. Finally, if wage or capital prices change, the slope changes. The line rotates rather than shifting parallel, like this. What do we mean by rotate? It is like this. This is rotation. K and L. This is called rotation, and this is also called rotation. K and L. This happens in case that one of the inputs prices increases or decreases while the budget remains the same and the other price remain the same. the line rotates rather than shifting parallel. And this happens when wage or capital prices change, so the slope changes. This shows that the change in input prices affect production decisions. Let us come to producer's equilibrium, and we have two approaches here. There are two ways to explain producer's equilibrium. The approach one, least cost combination. Here, the producer already knows the desired output level. Approach 2, output maximization. And here, the producer has fixed production budget. The objective is to obtain the highest possible output. Although these approaches seem different, they lead to exactly the same equilibrium point. That point occurs where the isoquant just touches the isocost line. So this point represents maximum efficiency. Condition for producer's equilibrium. This slide contains the most important result of today's lecture. Producer's equilibrium occurs where the isoquant is tangent to the isocost, just like this. We have this is K and this is L, and this is the isocost and this is the isoquant. So the tangency point represents the producer's equilibrium point. Okay? Why is tangency important? At this point, the slope of both curves are identical. So the slope of this is the slope of isoquant, and this is the slope of isocost. So when the slope of isoquant is equal to the slope of isocost, in this case we will have producer equilibrium. So when the slope of isoquant equal the slope of isocost, then we will have we will have equilibrium. So marginal rate of technical substitution equals the ratio of input prices, and this is the marginal rate of technical substitution here, and this is the ratio of input prices. This condition can also be written as marginal product of labor divided by marginal product of capital equal to wage divided by rental prices. So what does this mean economically? It means every dollar spent on labor generates exactly the same additional output as every dollar spent on capital. Suppose $1 spent on labor produces more output than $1 spent on machinery. The producer should hire more labor and reduce machinery. Likewise, if machinery is more productive, the producer should invest more in capital. Only when these two productivity ratios are equal does the producer have no incentive to change the input combination. This is true producer equilibrium. Let me now show you this very nice slide which summarizes the whole producer equilibrium, and let us interpret the graph. Notice the downward sloping straight line, the blue one. This is the isocost. This is the isocost line. The curved line, the green one, is the isoquant. Observe that the two curves touch at exactly one point, point E. They touch here at point E. This is the tangency point. We call it equilibrium point. This touching point is called the tangency point. So it represents producer's equilibrium when the isoquant is tangent at isocost, we call this equilibrium or the tangency point, and it represents a producer equilibrium. At this point, the firm achieves the highest possible output because at the isoquant we will have the highest output, and at the isocost we will have the least cost. Equivalently, it achieves the required output at the lowest possible cost. Any point inside the isoquant is inefficient. If we take an output here, which is less than the required output at the isoquant, so this is inefficiency because we do not use all resources to produce the highest output. And any point outside the let us say this is outside the isocost here, point C, and this is point B. So point C requires high cost. Okay, any point outside the isocost line cannot be afforded with the current budget. Therefore, the tangency point is the optimal production decision. Please read each statement carefully before deciding it is true or false. Think about the reasoning rather than memorizing the answer. You have to solve all these questions and upload it to my WhatsApp. Let us come to the closing, and this brings us to the end of today's lecture. Today we have learned the meaning of producer's equilibrium, isoquants and their properties, isocost lines and their characteristics, the marginal rate of technical substitution, the tangency condition for equilibrium, the economic interpretation of efficient input allocation. These concepts form the foundation for many advanced topics in economics, including production optimization, cost minimization, and profit maximization. In our next lecture, we will continue exploring more from microeconomics and try to apply these concepts to practical business decisions. Thank you very much for your attention. I look forward to seeing you in the next lecture. If you have any questions, please feel free to ask me in the private pages.